I'm going to show you the most common way that's sort of expanding out double brackets, and then show you a slightly different method called the grid method. What do I mean by expanding out brackets? Say we have x plus 4 and x plus 5. What does that mean? It means every term in this bracket gets multiplied by every term in the second bracket. Everything in the left bracket times everything in the right bracket. So one way of doing it is using the FOIL method. First out in last. So it should take this sort of form. That times that. That's the first two. So x times x is x squared. 4 times x is plus 4x. Now we're done with this term. We're going to go to the other term. First times that one is 5 times x, which is 5x, and then last times last, 4 times 5. You can even go down the bottom here, is equal to 20, and then we would collect those terms up and simplify them. Well, there's only one x squared there, so the x squared stays. These two are like terms, so we can add them. 4x plus 5x is 9x. They're done. And the last thing that's left is 20. That would be our answer. Okay, if we were to use a grid method, and this works best for really long equations times really long equations. So I'm just going to use the top one first. So I'm going to have plus x and then plus 4 there, and then I'm going to have plus x and plus 5 there. If you notice, this is the second term, things along the top are the first term. X times x is x squared, 4 times x is 4x, x times 5 is 5x, and 4 times 5 is 20, x squared, 5 plus 4 is 9x, and the 20 comes across. You get the same answer. This one though is most useful, as I said before, when there's lots and lots of terms that we have to sort of sort out. Let's have a go with another one slightly, ever so slightly tougher. X plus 3. And we want to expand out those brackets. Well, we can go first. X times x is obviously x squared. Negative 2 times positive x is negative 2x. And now we're going to go the second term. So x times positive 3 is 3x, and lastly minus 2 times 3 is minus 6. Actually, that should be minus. Should not. It was minus 2x. So now we collect up the like terms. X squared, 2x plus minus 2x plus 3x is just x, and then we have the minus 6 at the end. So far, so good. What about this one then, where both of the terms have a negative in it? Same thing again. X times x is x squared, minus 6 times x is minus 6x. We're done with the first one, now we go to the other one. X times negative 1 is negative 1x, and negative 6 to negative 1 is positive 6. Okay, the x squared stays there, so negative 6x, negative 1x, maybe we could just get rid of that so it just looks a bit clearer. Negative 6x minus 1x is minus 7x, and plus 6, and we're done for that one. Another example. X plus 7, x minus 3, minus wonky 3. Same again. Top to top. So x times x is x squared. 7 times x is 7x. So now we get to the second one. Give myself lots of room. X times negative 3 is negative 3x. Positive 7 times negative 3 is negative 21. And now we collect up all the terms. The x squared, that's the only one for that one. 7x minus 3x is positive 4x. And the 2 comes along. It's the only constant. Another one. Two x plus 1 x plus 4. Okay. Same thing again. First to first, 2x squared plus 1 times x is x. 2x goes to positive 4 is 8x, and lastly the 1 goes to the 4 plus 4. Collect up those terms. 2x squared plus 9x, 1x plus 8x is 9x plus 4, and we're done for that.